So hello, we are honored to have Mike Boyko, who's COO of Dynamic Water, with us to talk about all the things they're doing on a pretty large scale in the commercial industrial space. Uh, Good morning, Mike.
Yep, I appreciate the time and just the opportunity to talk about what we're doing and how we're helping save some water.
So why don't you just brief us on your background and Dynamic Water?
Sure. Yeah. So I've been in the pollution control equipment sector for the last 30 years, really focusing on heavy industrial users, power plants, mine sites, industrial manufacturing. I selected that market because I felt I could do a lot more good in those spaces because of the remarkable consumption and pollution generation. About 10 years ago, I had the pleasure to work with a current U.S. Energy Security Council member, John Hofmeister. He was on my board of directors for 4 years. And he instructed me that one of the critical areas of the world is going to be water. And he said, really, you need to focus all of your time and energy on that. And so for the past 10 years, I really spent almost all of my energy and effort on water and wastewater challenges. Ideally taking technology that has been either underutilized or maybe undermarketed and help commercialize it in the industrial and large commercial arenas where it can do the most good. And so that's really what I've spent my the last 10 years of my life is developing, incubating, expanding, and commercializing industrial process water treatment technologies.
Hmm. That's an interesting approach. So, are there specific markets that you focus on, or is it?
Yeah, I mean, what we're trying to do is you can imagine the more water intensive applications. Comfort cooling certainly is something that we do. So you look at large high rises, malls, things of that nature, which we certainly do treat cooling towers and help them reduce their water consumption, reduce their sewer discharge, reduce or eliminate the need for chemicals by treating it with a different process. But we're seeing a lot more benefit in cold storage, data centers, industrial manufacturing, mine sites, power plants, petrochemical facilities. These are all very large energy and water consumers. And we do like to talk about water and energy together because, water and energy are the same. You call it the water energy nexus. You need one to produce the other always. And so, we always tell people that, you want to conserve both elements as aggressively as you can, and we are a realistic group in that whatever we do has to have a cost-effective baseline. We talk a lot with our customer base, and we know that there has to be a reasonable return on investment, otherwise the markets just won't adopt it.
Mm-hmm. Yeah, and obviously, well, your projects are typically um, major scale, as
Yeah.
well. So, um,
Well, what's
yeah.
interesting though is that, we have, and I've always said that until about a year and a half ago, when two of the largest grocery store companies in the country came to me. We're looking at actually helping them on their distribution centers, and they told me that while they really like this on the large distribution centers, what about their stores? And I said, well, typically we haven't been targeting stores because there's, the tower is probably a 120-ton cooling tower. It'd be difficult to just do a few of those. And they said, well, we're not talking about a few of those. The one grocer has 3,300 of those. The other one has 2,500 of those. So they definitely got my attention. We actually developed, this is a little model, a scale model of the unit that we built. The full scale system is actually 6-inch diameter tubes, 4 foot long. And it's a reactor technology that allows us to eliminate the need to add chemicals and allows them to cycle at a much higher rate. And what was shocking is that the stores individually are running very low cycle rates. And so those individual stores are wasting about 1 million to 2 million gallons of water a year, which we can now recapture and save. And so all of a sudden, when you start talking 1 million gallons times 3,000 stores, that's a major success. So.
Yeah, I mean, one statistic, I remember in terms of cooling towers, is something along the lines of if it was single pass, um, cycle, that it would be I forget now what it was, but it was like 2 gallons per hour per ton or something like
It's
that.
it's shocking. I use this actually in one of our brochures all the time. And so you can see this is a cycle grapher, and basically you're here if you're one pass.
Yeah.
As soon as you get to 2, 3, 4. And I mean,
Yeah.
I always tell people 10 is your goal. If you can get to 10 cycles, you've done your
Mm.
work. But so many places we come across, the average in Arizona and California, Nevada, is somewhere around 2.5 cycles of concentration. And it's really ridiculous when you, especially in some of the areas in California that have very good quality water, to be running that low of a cycle rate. But it's the back of the house type of mentality. No one thinks about it because it's either on the roof or in the back of their facility. It's not a big deal. But then they start realizing just how much water they're actually using. We do calculations and projections and measurements. A lot of times they don't have meters in place. And we say you have to have meters.
Oh,
You've got to, makeup and blowdown meters, and makeup at least. And we've been putting them in a lot of different facilities. Like SoCal Gas has been a great partner of ours, and they agreed with us. They said, yeah, if you don't measure it, it doesn't matter. So we've really had some great successes with groups like SoCal Gas, Kaiser Permanente, City of Los Angeles. We actually got Innovation of the Year last year for the City Hall installation we did back in 2018. That was actually vetted by the Department of Energy, and but the city was actually awarded the Innovation of the Year for water savings on that project.
so you mentioned, I want to just get into a little bit, just an overview of technologies. It sounds like you operate a kind of an island for lost toys or something,
Little bit.
underappreciated technologies, or maybe you're taking the old Oakland Raider approach to
Yeah.
uh, in terms of
Yes.
bringing in players that are undervalued. I guess it's more
Yeah.
Moneyball kind of stuff. But
It is. It's
anyway,
a lot.
yeah, if
Yeah,
you can
definitely
just
Moneyball.
maybe highlight some of the things that you're doing. You mentioned that little model with the cooling tower.
Yeah. So yeah, these reactors that we've developed, it was a technology that's been around for about 30 years, and it's electrochemical. So what happens is you have a titanium anode in the center of these carbon steel shells. And what happens is when you put low voltage DC current, you create two different things. One, you're generating chlorine from the water itself, so you don't add any chemicals. Two, you create a pH gradient that allows scale, actually the mineral scale from the process, or from the drinking water, because drinking water is what makes it up. We actually remove that. You can kind of see this is calcium magnesium from drinking water, and we pull that in our reactors. So what's nice is we can control scale. We put the scale where nature wants to put it, in a high pH gradient inside in that reactor shell. So it really allows us to increase that cycle rate and improve the overall efficiency of the operational facility. LA City Hall, for example, actually had scale in their tubes, which it wasn't bad. They were actually running a very efficient process. This is actually before we started. So they had some scale on the tubes themselves. In 3 months, we actually pulled all of it out. 6 months after that, 6 months after that.
I love these props, by the way. You have all these handy props. We're not talking PowerPoint here.
No, and I do PowerPoint as well, but a lot of times my conversations are quite fluid. And so it's nice just to grab things and talk about.
No pun intended.
Absolutely. No, it works quite well. But I love the visual impact. And that's one of the things I wanted to talk about, that you can run a better system with technology. And when you said the kind of the island of misfit toys, there are technologies that have been underutilized, underappreciated, undermarketed. One of the primary technology was actually represented by one of the largest chemical companies in the world. And unfortunately, when this other chemical producer bought them, they looked at the technology and said, why would we back a technology that reduces the chemicals that need to be used? So unfortunately, it was put on the shelf for 4 years. Now, fortunately for us, we identified it. We're able to take the technology and really run with it. So these are things that I always talk about. There are solutions that are available, but they need to be really implemented. They need to be adopted and implemented in an aggressive manner. I always talk and speak with a sense of urgency. and I've done this for years. I grew up in the desert. I know what it is to live in water scarce areas. And I think a lot of people just don't have that mentality. They see the green lawns, they see the trees and the golf courses and everything else. Oh, there's no problem. There's plenty of water. But the reality is we've been drawing water from aquifers. We've been pulling water from other resources that we've had. And this is not supportable, and it cannot be sustainable. Lake Mead this year, the Bureau of Reclamation already announced that by the end of this year, it'll be at 1067 lake level. But at 1075, which is going to happen in July, the tier 1 restriction will actually be put into effect, which means 40% of Arizona's water allocation for the Colorado will be cut. This is a massive impact. Hundreds of millions of dollars in farming will be lost. It'll go fallow because they won't have the water to support it. And the same thing's happening in all 7 states that are supported by the Colorado River. So there are some very real things that are happening this year that we've been talking about for the last several years. And it's finally come to pass that this is the year. This is what's going to happen, that water is highlighted now. People are finally realizing that this is a major crisis. And hopefully that'll get people to move with a little bit more urgency and start implementing conservation technologies and different methods to start saving.
Well put. You got me thinking too. There's so many maps right now in the orange and reddish brown kind of areas in terms of dryness, and thinking about the West basically being comprised of desert and high desert.
Yeah, I look at the U.S. Drought Monitor regularly, and I always tell people to really embrace that document and to understand what it is. One of the things so just so you don't think I'm completely ignorant of computers. So
not at all. I saw this as going beyond 3D.
So well, you mentioned this. You're right. I mean, you look at this image and you see it, which was just updated actually today.
Yeah, it's
shocking. It is absolutely shocking what we're dealing with. The entire Western United States is in drought, and this is getting worse. The NASA came out 2 years ago with a prediction saying that the drought that is currently happening right now is the worst drought in 1,200 years.
Yeah.
We're getting drier, where we have less water resource available. The Central Valley, I don't know if you may be aware, but the Central Valley, the actual land itself in many places has sunk up to 30 feet in the last 100 years because of the aquifers being drained. I mean, these are almost apocalyptic events and that have been glossed over for a long time, because the aquifers in California and the Central Valley, they've already said will not recover. The clay layers have fully collapsed, and so there needs to be a completely new strategy and plan on water storage, on reservoirs, which are not going to be easy to permit. There's so many different things that need to be changed fundamentally, and largely what we talk about is, and I won't get into politics, but there needs to be more money spent on water and wastewater. Just on across the board. It has to happen. And I don't even believe that there is wastewater. There is process water. Every drop we have, no matter how contaminated, is a resource. And we just need to figure out how to harness that resource and utilize what we have in a much more intelligent way. I talk about this in most of my discussions, that, we flush our toilets, we water our lawns, we wash our cars, we run our cooling towers with potable drinking water. That's outrageous. So there are some cities in California that have implemented a purple pipe program. Santa Clara, I believe, has that in place. It's not very widely utilized yet, so I'm hoping that gets a larger adoption. But there's
when I chaired USGBC California for a long time, statewide policy organization, and we did work with Mike Gatto to sponsor the Purple Pipe Bill. It was very problematic, had terrible implementation, and a judge in San Diego basically shot it down. So it's, although we also did we're big supporters of the car wash bill in terms of recycled water and
Yeah.
reuse in car washes. So when we talk about, basically anybody will listen, that's washing their car in their yard or something, no, you need to go to the car wash.
Yeah.
They get a number of exchanges of water on that. And,
we actually have a new technology that we're just finalizing for car washes. We had a very large car wash group that owns and operates 350 locations across the United States. And we actually have a new technology that combines a couple of these cylinders with a side stream filtration process to sanitize it, to pull out the material fines. And the effect has been spectacular. So we're going to be rolling out that technology in a number of different car washes. And then they've already told us once they have that evidence of function, they want to put it in every one that they have and put it into all the, help basically roll it out into the industry, because there's 30,000 car washes across the United States. It is one of those unusual places that I think a lot of people don't think about, but where does that dirt and oil and grease and all the other stuff go? Well, normally it's been going in the sewer. So
right. And so anyway, I mean, that is actually a major kind of marketing thing for the car wash industry writ large, if they have this in that a reason to go there.
Yeah.
And that people don't think of right immediately. You're not except for like oddballs like me, I'm going in the car. I have the dirtiest car in the neighborhood, but I won't go to the car wash. I'm not going to use potable water on on the cars. We'll get it in there. Are there other we're not quite in the light, we're in the thunder round. So I just wondered if there were other kind of case studies or just examples of things that you're working on, especially if you have props for them.
Yeah, no. So, one of the things I like to talk about, we're working extensively with large industrial process like steel mills. And these steel mills, we're actually, this is an example of some of the projects we're working on. So they have wastewater in their process. They're losing about 100,000 gallons of oil in one circuit every month. And so they can't stop because their production is so critical. But they were struggling with this material. They really couldn't do anything with it. And so we put it through a technology that was first patented in 1906. And we're able to split the water and actually produce this really high quality process water by using zero chemicals, low voltage DC current, and a 11 micron filter, which is a very porous filter. The great thing about that is it's far more effective. And they came to us and basically said, our chemicals aren't working. What else can you do? Is there something else you can do to help us with these different streams we have? And I said, certainly. It's funny that one that looks terrible, the black, water itself.
You go from coffee to parfait to water.
Well, so yeah, there's another good one here. I'll share my screen with you again. So, there's several processes, but like this water here is some of that splitting water that we did. But the one that was kind of interesting is this one. This homogenized blend that we had here was, can you see that image?
Yeah.
Okay. So this homogenized blend was actually very problematic for them. See if I can bring this up here. Okay. Is this still on your screen?
It is in smaller view.
Okay, hold on a second. Let me stop share and then share, and then here we go. So this one here it's actually an oily waste from a homogenized blend. So that homogenized blend, when they talk about like a cappuccino or something, some people said, "Oh yeah, it looks like what I get in the morning." This was not being able to be split efficiently because the oils were fully homogenized. What we were able to do with this, what's called electrocoagulation, low voltage DC current and iron plates, we're able to basically cause that splitting of the material and then putting it through a series of filters, zero moving part type of filtrate technologies. We can actually clean the water very efficiently. And the nice thing is, we're not adding any additional foul elements to the water. We're able to take heavy metals, base metals, oils, fats, greases, and separate those elements very aggressively and very efficiently. Typical cost comparison to using chemical flock is usually 3 to 5 times less expensive using electrocoagulation, which again, fundamentally is a very old school technology. But it has not been, I'd say, well packaged or well marketed to the industry, largely because the chemical industry is really the dominant group that's out there. And I think it's a lot like the pharmaceutical model. There are a number of companies that really don't want to cure the diseases. They just want to treat symptoms because there's a lot of money in that. And unfortunately, I think there's a lot of incentive to stay using chemicals instead of using a technology that can basically strip out the foul elements and provide a usable resource on the back end. So we really pride ourselves on taking these under-recognized, underutilized technologies and packaging them in a way that is cost effective. And we can go into our clients and say, from day one, you're actually saving money. So this is not a cost impact to you. This is actually a cost savings for you.
That's well put, especially too with these technologies don't have the, I'll say, the IP overhead that a lot of things would do.
Yeah.
So common sense is not so common.
No, and yeah, we spend a lot of our days trying to explain to people why it works, how it works. The industry has been a little bit abused by people out there who didn't understand how certain technologies would work, and so there's always that story of, oh, this I've tried this 20 years ago and it didn't work, and I kind of come back on that and say, well, okay, so you just stopped trying 20 years ago. We can't afford to not try. There's always challenges with technologies. There's always challenges with anything that you're going to do. But fundamentally, as far as I'm concerned, when it comes to water conservation, we have failed. We've failed to save water. And now the day of reckoning is upon us. We need to get on task here and start treating water as a precious commodity, because it is. And now all of a sudden people are raising their arm and saying, hey, yeah, I want to try something. I want to be part of the solution. We just have to. There's not another choice.
No, certainly not. And obviously, I think this current round of drought, certainly Western drought, is concentrating the mind.
Yeah.
And I've been and just this issue of overall dryness, atmospheric dryness. I mean, where even the humidity levels are noticeably lower than
Yeah.
past measurements. So this is a whole new ball game. And then also with in part and parcel, at least around us, is the wildfire issue as well.
Yes.
And but it's all in a way part of the same effect in terms of the changing conditions.
Well, this is something that has happened, century over century, eon over eon. In Arizona, where I'm at in Phoenix, the Anasazi and Hohokam tribes here left the Phoenix Valley, 3,000 years ago. And it was likely because they had situations where the drought conditions just necessitated it. They didn't have a choice but to move to somewhere where they had available water. And this is not that remarkable of a situation that we find ourselves now. This is something that's happened before, and it's going to happen again. And we need to have an action plan and a strategy to deal with this. And so, that I bring up this because, some people want to say, oh, well, it's climate change. And other people say, oh, it's not that. It's like the climates have shifted, whether it's man-made or just natural phenomenon. There's a reality is we are drier. We are in a water scarce area. California, as an example, is a Mediterranean climate for the most part, which is a wonderful climate. There's 6 areas in the world that have the Mediterranean climates. The problem is they are generally water scarce. So, you go into Los Angeles and you're thinking, oh, it's nice. This is a nice area. The weather's perfect, but it is dry. And
yeah,
people don't consider that.
And all these climates are usually on rings of fire
Yes, yes, that's
geologically, you know, as well.
yes, they
So,
are. They are.
but you mentioned actually indigenous people and using, and I mean, which to me is you know, if we were talking before about unappreciated technologies, and then
Yeah,
take it to like indigenous people's practices, like
yeah,
prescribed burning, for
yeah.
instance.
Good point. Yeah,
You know, that kind of fits very well with, in a way, with your say business technology model.
yeah, absolutely.
You know, looking at ancient technologies
Well, and
and
you know, I mentioned I
approaches.
think a while back that you know the Hopi Indians have a dry farming technique, and so they don't even water some of these very dry areas, but they have a method that's worked for thousands of years, where they can actually grow maize and grow some other types of produce without irrigating. And because you know that is another major, in
Mhm.
fact, it's the major consumer is irrigation, and I would say irresponsible irrigation. You know, flood irrigation is it can't be continued. It's a fact. It can't
It's
be
yeah,
going down the, you know, I've been to Israel twice, and the Israelis are remarkably adapted to dry climates, and they're the pioneers of drip irrigation. You know, I mean, that is a much more responsible method for irrigation of crops, and for farming and agriculture in general. The flood irrigation is just, it's completely unsupportable. And you know, if you look at the actual consumption of water across the board, flood irrigation is a massive consumer. I think it's number one of all other water consumers.
yeah, it's like evaporative irrigation, I
It is,
suppose.
seriously. Yeah, it's
Um,
pretty shocking.
you got me thinking about this weekend's plans for
Mhm.
planting early girl tomatoes with dry
Yep.
farming.
Oh yeah, yeah.
And
Be interesting.
we'll give them a little water in the beginning, but then they're on their own. And you know, hopefully that will. And in past, it's been good. It really concentrates the flavors. And
Yeah,
obviously, if you're you know, growing grapes in Sicily or something, you know, in volcanic soil, you have an idea about this as well.
yeah,
And so you know, that, I mean, perhaps is something to, you know, makes a tough transition if you're talking about traditional
yeah,
large farming approaches, but yeah, there's certainly need, well, needs to be on in the field, but also I know just even say in the lettuce and greens industry and the processed water that is used for the convenient
yeah.
packaging, you know, is a big deal. And I know there's a lot of work in that as well.
Absolutely. You know, that's just another one of those they're difficult discussions to have, because people don't want to alter or change what they're doing right now, but fundamentally we have to. You know, the process industry, the cold storage industry, you know, all of these groups need to modify how they work and need to make changes. You know, I'm not suggesting that we institute, you know, draconian style water restrictions. I'm suggesting that we incentivize savings technologies. And I give Nevada a heck of a lot of credit. The Southern Nevada Water Authority instituted
Mhm.
last year a $15 per thousand gallon water rebate for water savings, which is spectacular. We just did a project for Americold, and 1/3 of the entire project cost is coming back to them on the rebate. So it's a spectacular incentive. And I'm hoping that many others in Southern Nevada actually follow suit to Americold. Americold's been a great partner for us, and we have several other cold storage companies coming online right now that we expect to have similar relationships with as well.
Well, I appreciate this conversation and you know, really this realization that smart water strategies are good business and
Yeah,
really need to be supported. And so, for instance, these performance-based incentives,
absolutely.
you know, that they're not super prescriptive, but it's
Yeah,
like how you know, what's the result, I
yeah,
think is a really great way to go. I know locally here, Valley Water's been doing some interesting things in that, you know, particular area. They shifted their incentives quite a bit where they're not necessarily telling people what to do, but
Yeah.
starting to look at the overall efficiency over time.
Yep.
Well, anyway, thanks so much for joining us and um, giving us a view as far as what's going on with dynamic water and the drive to get more value out of this precious resource.
Yeah, I appreciate the time very much, and any time that we can just increase just the general public's awareness of better ways to do things, we sincerely appreciate it.
Well, great. Thanks again.
Okay, no problem. Appreciate everything.